just going to have a look here at doing out this perspective question. Okay, so it is an old ordinary exam question. So it just says the 3D graphic on the right shows a child's playhouse which is made from plastic. Okay, so we can see our 3D graphic here showing the child's playhouse. Okay, so it is basically, it just looks a simple box gable on each end and another little one extruding out from the side, and the inside of it there is open and a little rectangular window cut out as well. Okay, so it says figure B2 below shows the plan and elevation of the structure. Okay, so we have the plan down the bottom and we have our elevation. Okay, so draw the given plan. So that's the first thing we need to do, is this view down here, that's what we draw. And we're going to be drawing that up at the top of our page, kind of position it probably closer to the left hand side, because imagine our perspective view will shoot slightly to the right at the bottom. Okay, so make a perspective drawing of the structure given the following information. The spectator is 1440 millimeters from corner A, picture plane is touching corner A, and the horizon line is 1000 millimeters above the ground line. Okay, now those measurements appear very big, but there is a scale of 1:20. Okay, so we need to scale down, we need to shrink down our drawing there by a scale of 1:20. So all of those measurements that are on it, basically what we need to do is we need to divide all those measurements by 20 to solve this drawing to get it to fit in our page. Okay, so it says the spectator point is 1440, so divided by 20, we said that'd be 72. Okay, so straight away on the question I'll cross out the number and I will write what it is in my actual scale. Okay, and it also says that the picture plane or the horizon line is 1000 millimeters above the ground line. Okay, so the horizon line being 1000 millimeters above the ground line, so if we divide our 1000 by our 20, okay, so that's going to change then to 50. Okay, so we do the same for the rest of the drawings, so just cross over the number and write the scale measurement there straight away. Okay, so 600 here, that's going to become 30, 1200, that's going to become 60, 350, that's going to actually become 17 and a half. Okay, so that's awkward enough, so 17 and a half, that's 17 and a half as well. The 600 again is 30. Okay, that 800 there is going to be 40. So I'm just dividing all these by 20, that's all. Okay, and the same for these ones, that becomes 40. The 500 there, that's going to become 25. Okay, my 400, that becomes 20. 700, that becomes 35. And the 300, that's going to become 15. Okay, so straight away I cross out all the full measurements and I write the scale, the measurements on the drawing there instead. Okay, of course angles never change, an angle will not be scaled, it'll stay the same no matter what. Okay, so it's just all the measurements need to change, and after that then I'm just going to go now and draw my plan up at the top, closer to the left hand side of my drawing, of my page there. Okay, so I'm just going to work away and I'm going to get that done there first. Okay, so there I have the plan view of that house drawn as it is given in my question. Okay, I have my corner A. Okay, my question, so that's my front corner, my corner A, or my edge A, so that's it right there in the actual drawing. Okay, so that's my edge A, and it basically the picture plane is touching corner A. Okay, but first of all I want to locate my spectator, so he's 72 mil directly below corner A. I can see that from the direction of the arrow is going there, that's straight down below corner A. Okay, so just draw it in lightly, and he's down a distance there, or she's down a distance of 72 mil below that corner, so 10, 20, 30, 40, 50, 60, 70, and 72. Okay, so there's my spectator there. Okay, so I label him as S. Okay, so as always, put in our cone of vision. So our cone of vision is when we look at the two outside corners. So the spectator looks at that corner, and our spectator looks at that corner there. So there's our cone of vision put in. Once our cone of vision is put in, we need to locate our center line of vision. Okay, to get that, we bisect our angle. Okay, so this angle down here, we're going to bisect that angle. So there's no compass. Point on our spectator. So right there on our spectator, and then we can swing an arc. Once that arc is swung, I'm going to just widen the compass a little bit. Once that arc is swung, okay, so from our point here, and also from our point here, we swing two arcs at the same radius, they cross over, that's a point on our center line of vision, and we connect that just back to the spectator. Okay, so for that, I'm just going to put it in a red. Sharpen up my red pencil. I put in my center line of vision. So from the spectator, my bisector, that is now my center line of vision. Okay, our picture plane has to go 90 degrees to that center line of vision. So a picture plane for all the world is like a big sheet of glass. It comes up 90 degrees to the center line of vision, and it touches right there on corner A. Okay, set up a 90-degree line there first. So just use my set square, line it up with my center line of vision, and I just want to slide it down in with my other set square, and it just touches corner A. Okay, so that's my picture plane, and I can extend it then. That's my picture plane in position. Okay, so just label that as picture plane, my PP. Okay, picture plane. Okay, now what I want to get is my vanishing points on my picture plane. So as the spectator is looking at the object, he looks out in that direction. So where do the vanishing points go? Well, we need to go parallel to this edge here, and parallel to our edges going in the opposite direction. So from my spectator, I'm going to go parallel to those two edges. Okay, so from S, so this one now is parallel to all my edges going that direction. So that's my VP1, and the same for the other one. From the spectator, we go out there, and that locates VP2. Okay, so that's the plan view of everything. Now I need to start drawing the 3D view of it. Okay, so it's at this stage now that I will normally reposition my sheet. So my T-square, I want it in line, or I want it parallel with my picture plane. Okay, as we can see, my T-square is definitely not parallel with my picture plane, so I'm going to make it parallel with it. So I basically reposition my page, got my tape, put it back on in a second. I'm going to twist my page so my T-square is lined up, or to my page I should say, is lined up right on my T-square. Okay, so I'm happy enough with that there. And it just makes the rest of the drawing fairly simple, and I don't have to use an adjustable set square or sliding set squares or anything like that. I can just continue on as normal. Okay, so there's my page repositioned in line with my T-square, and I can now put in my ground line and my horizon line, and it says there that my horizon line is in a scale down 50 millimeters from the ground line. Okay, so I'm going to put in the ground line first, so nice and low on the drawing. So I'm just going to adjust the camera here. Okay, so I have my plan. I'm going to come right down my page, and I'm going to put in my ground line. Okay, pretty low on it. Okay, I should have enough space there. Okay, so I'm going to call that my ground line, and my horizon line is 50 millimeters above that. So I can just measure up straight from my T-square, my set square, measure up 50 millimeters, mark it off, and draw in another line parallel to my ground and my picture plane. Okay, and that there, that's my horizon line. Okay, so horizon line. So what I want to do now is I want to locate my vanishing points on my horizon line. And all I need to do for them now is drop them straight down, and drop this lad straight down, right down onto my horizon line. So let me get my set square. So VP2, pencil on the point, set square over to it, drop it down, and the same for VP1. Drop it straight down. So that's vanishing point 1. Here we have vanishing point 2. Okay, right there on the label. It's on the same label for the horizon line. Maybe I should have moved that label further over to make it neater, but anyway. Okay, so that's the setup of the question. The setup of all the questions are the very same.